Hello, today my talk is about observation of Mesospheric front over the Brazilian low latitude. This work has been developed at Federal University of Campina Grande. The main motivation for this work is based on the fact that we can observe large fronts in the mesosphere and the lower thermosphere that we call mesospheric fronts. And this mesospheric front can be bore-like front, wall, and the characteristics of this front can be investigated using air glow imaging. In this work, beside the images from 08, 5577 and 02, we are going to use the meteor radar and the LiDAR to investigate the background of the atmosphere where the fronts are propagating. Those picture shows on left a mesospheric bore observed in the night sky over the mountain Balong. On right we can see a kind of ondular bore in the Brazilian river. Actually, we can use the fact of the air glow layers come from different altitude, as we can see on bottom right. 08 is come from by about 87 kilometers, 02 from 84 kilometers altitude, and the OI 5577 from 93 kilometers altitude. When the ball propagates through these layers, we can observe different patterns in the images, as we can see here on right top, and based in this complementary pattern we can decide which altitude is the duct where the front is propagating. The instrumentation used in this work are basically an air glow imager located at Cachoeira Paulista, a meteor radar that is going to be used to determine the vertical profile of the wind located at the same site, and at São José dos Campos we have using a LiDAR to investigate the vertical profile of the temperature. The methodology basically consists in calculation of the gravity wave parameters. After that, collect wind and temperature data in order to investigate the likely ducts where the front are propagating, using the complementary pattern to decide which kind of front we are observing, and another bore requirement to decide if the front is a bore or not. Here you have an example of the methodology. On left we can see the pre-processing of the images when we start correcting the geographic position, the geographic coordinate of the images, apply bandpass filters. When you have well defined the wave patterns, we can calculate the parameters of the gravity waves, the training waves behind the board, using a two-dimensional spectral analysis. On right, we can see a chart where you have temperature, Brunt-Väisälä frequency, wind, m square, Brunt-Väisälä over c minus u. U is the wind in the direction of the wave, and the second derivative of the wind as a function of the altitude. All those information are calculated closest to the passage of the ball in the field of view of the image, and using those information we can decide where is the duct and what are the most important terms to the formation of this duct. As results, we have here the first case study on 14 September 2007, where we can see in the airflow images a complementary factors pattern. The first front is bright, the second the second image which is the O02 is dark, the third one which corresponds to OI5577 is dark. If we observe the background of the atmosphere, we can see there is a duct located between 82 and 92 kilometers height. The duct is characterized when the m square is positive, between two negative values. In this case, both the temperature and the wind were mandatory for the formation of this duct. In this case, we call it is a dual duct. The second case study was observed on 5 October 2007, and we can see on left the complementary pattern from the airflow images when the fronts are dark, dark, dark. If we investigate the background of the atmosphere, we can see there is a kind of duct between 80 and 83 kilometers height, and the temperature, the second term, that means the 5 chart here, was decisive for the formation of this duct. The third event was an interesting case because we could observe a mesospheric front on 5 March 2008, but there was no clear images from the other emissions. We could observe only the 08 airflow in the 08 image. It is not possible to define the complementary pattern, and another thing interesting was because we investigating the background of the atmosphere was not possible to define a duct as well. Event 4 was observed on 31 March 2008. The complementary pattern was dark, 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 and it is a thermal duct located below around 87 kilometers height. The last observed event presented a complementary pattern, bright, dark, dark. Checking the background of the atmosphere, we could conclude that it is a thermal duct located below 87 kilometer height, and it was observed on 3rd September 2008. As a summary, we have the spectral characteristics of the gravity wave, the training waves calculated from the spectral analysis. Most of the wavelengths were located between 30 and 48 kilometers. We have some periods that varies a lot, from few minutes up to 700 minutes. The phase speed was concentrated between 10 and 74 meters per second, and most of the waves are propagating to northeast, to the southeast of Cachoeira Paulista. This is the first simultaneous observation of the Mesospheric front in Brazil using the all-sky image, meteor radar, and LiDAR instrument. From this work, we can see that ducts were mainly caused by the temperature effect, that means more thermal duct. This work is in agreement with D1 NPK 1998 complementary pattern. It was also observed that most of bore in this work were propagated to the northwest and southeast direction. And this work was proof that the duct size of 2.5 kilometers and above is capable to offer propagation condition for the Mesospheric front. I'd like to thank the Conselho Nacional de Desenvolvimento Científico e Tecnológico for supporting this research. I thank also the Federal University of Campina Grande for supporting my participation in this meeting, and thank you for your attention.